Hey guys, welcome back to Code with Us YouTube channel, and we are with one more video of operating system in the web series of second of video. So let's get into the next thing which we are going to see. So what is operating system structure? In this operating system structure, we'll be seeing about multi-programming or batch system, which is nothing but this batch system is needed. Mainly, we use this batch system for efficiency. Single user cannot keep CPU and input-output devices busy at all times. So any single user can't keep the CPU and the IO devices busy all the time. Multi-programming organizes jobs like code and data, so CPU always has one to execute. If multi-programming is there, both can be executed, like code and data can be executed always as one to execute in the multi-programming. Coming to the subset of total jobs in system is kept in memory. One job selected and run via job scheduling. So here what is job scheduling? Job scheduling is nothing but is a process of allocating system resources to many different tasks by an operating system. Which system can handle and prioritize job queues that are awaiting in the CPU time, and it should determine which job to be taken from the queue and the amount of time to be allocated for the job. So in this job scheduling, there will be many jobs coming in a queue based on the time taken, CPU time taken, which are waiting on a queue, waiting time, based on that it will be sent and the jobs will be completed. So that is job scheduling. Coming to when multi-programming, when it has to wait, OS switches to another job. Like if a particular job has to wait, then it will switch to the another job. And coming to the next thing, which is time sharing or multitasking. The operating system can be multitasking, which is a logical extension in which CPU switches job so frequently that users can interact with each job while it is running, create interactive computing. Using this time sharing, which is a multitasking, and also which CPU switches jobs so frequently that user can interact with each job while it is running, creating interactive computing. Coming to the response time of this time sharing should be less than 1 second. So for this time sharing, generally that response time should be less than 1 second. Coming to each user has at least one program executing in the memory, which is called the process. In the memory, there will be at least one program executing. That is called process. If several jobs ready to run at the same time, we manage these things by using CPU scheduling. We are having, as we have seen already, the job scheduling. Here we are seeing the CPU scheduling, which is nothing but if several jobs ready to run at the same time, which is called CPU scheduling. In this, time sharing will give a time of which time sharing will be shared by the each process, and that you based on the time sharing we will jobs will be running at the same time. If processes don't fit in memory, then the swapping moves them in and out to run. So any of the processes doesn't fit in the memory, then swapping takes place and move in and out to run the process. The virtual memory allows execution of process not completely in the memory. And next, general purpose of OS is very large program. Various ways to structure ones. Simple structure of the OS is MS-DOS, and more complex is UNIX, and layered one is an abstraction, and microkernel, which is used in Mac OS. So these are the operating systems, which is simple structure like MS-DOS, More complex is Unix. Layered is an abstraction, and microkernel is used in Mac OS. Simple structure, which is MS-DOS, which is written to provide the most functionality in the least space, which is not divided into further modules. Although MS-DOS has some structure, its interfaces and levels of functionality are not well separated. We are having ROM, BIOS device drivers, which are connected to MS-DOS device drivers. Resident system program is connected to MS-DOS device drivers, and which is further connected to ROM BIOS device drivers, and even resident system program is connected to ROM BIOS drivers directly, and application program is also connected to ROM BIOS device drivers directly. So this is what each and every like application program, resident system program, and MS-DOS devices, which are directly connected to the ROM BIOS device drivers directly in the MS-DOS. So which is a simple structure we will be seeing in this MS-DOS. And coming to the next, which is a more complex or non-simple structure. We can call the Unix as more complex or the non-simple structure, which will be with a high level of thing. Unix is, which is not a simple structure, which will be having a high level of thing, and more complex, not understood easily. Unix, which is a limited by hardware functionality. The original Unix operating system had limited structuring. The Unix OS consists of two separable parts. One is system programs and the kernel. Coming to the kernel, which consists of everything below the system call interface and above the physical hardware. This kernel consists of everything below the system call interface and above the physical hardware, which provides the file system, CPU scheduling, memory management, and other operating system functions, a large number of functions for one level, which is kernel. So as we have seen, the Unix will be having two parts. OS consists of system programs and kernel. And next.
And hello guys, and let us continue with the system structures. And this is the Unix system structure, which means this is the diagram for the more complex structure. That means non-simple structure. It is a Unix system structure. That means the first thing is it has users, and the second, the shells and commands, compilers, and interpretation system libraries. And here the system call interface to the kernel. It means this part is the kernel mode. So here the signals, terminal handling, character, IO system, terminal drivers, and the file system, swapping, block, IO system, disk and the tape drivers. And the third one is the CPU scheduling, page replacement, demand, paging, virtual memory. And this is the system call interface to the kernel. And this part is kernel interface to the hardware. It means the terminal controllers, terminals, and the device controllers, disks and tapes. And next the memory controllers, physical memory. So let's see the next another structure, which is layered approach. So in the operating system is divided into a number of layers, that means levels. So each built on top of layers. The bottom layer means layer 0 is the hardware. It means this is the hardware layer, and the highest, the layer n, is the user interface. It means the last layer. It is layer n, and it is the user interface. So with modularity, the layers are selected such that each uses function like operations and services of only lower level layers. So let us see, the layered structure is a type of system structure which is different services of the operating system. And so it was created, the layered approach, it was created to improve the Pre-existing structures like the monolithic structure, it means Unix, as we discussed in a previous slide, and the simple structure, which is nothing but MS-DOS. So example is for the Windows NT operating system uses this layered approach as a part of it. So let us discuss the what the layered approach is and what are the layers. Now let us see in a brief. So the design analysis of the layered approach. So the whole operating system is separated into several layers as we discussed before. So from 0 to n, from 0 to n, as the diagram shows, here the diagram shows. So each of the layers must have its own specific function to perform. So there are some rules in the implementation of the layers. So let us discuss the rules, and I will tell the rules. What are the rules? So the first one is the outermost layer must be the user interface, which is nothing but the layer n. This is the outermost layer. So this layer n is the outermost layer. So this must be used by the user interface layer. It means this is the user interface. And the second one is the innermost layer must be the hardware layer, which is nothing but the layer 0. So this is the innermost layer. So this is the hardware layer. So the third one is a particular layer can access all the layers present below it, but it cannot access the layers present above it. So that is layer n minus 1. Let us consider that is layer n minus 1 can access all the layers from n minus 2 to 0. It means let us take this layer. So this means this is n minus 1 layer. So this n minus 1 layer can access all the layers from n minus 2 to like from 0, but it cannot access the nth layer. It means it cannot access the outermost layer. So these are the rules. So thus, if the user layer wants to interact with the hardware layer, the response will be traveled through all the layers from n minus 1 to 1. So each layer must be designed and implemented such that it will need only the services provided by the layers below it. So this is the layered approach. So, and the next one we will discuss the microkernel system structure. It's a very important structure also. So it means the microkernel structure, it moves as much from the kernel into user space. So match, example of microkernel. Match, MACH, it is an example of microkernel. So Mac OS X kernel, it means it is Darwin, partly based on match. So communication takes place between user modules using message passing. So the communication takes place by passing the messages. So the benefits of these microkernel structures are easier to extend a microkernel and easier to port the operating system to new architectures. And these are more reliable. It means less code is running in kernel mode. It means more secure. The kernel system structure is a more secure. The detriments are the performance overhead of user space to kernel space communication. So now we can discuss about the structure of the microkernel system. So like what are the things in microkernel? Let us discuss. So the microkernel is the minimum software that is required to correctly implement an operating system. So it means the microkernel system structure is very important. That this microkernel system structure includes memory, process scheduling mechanisms, and the basic inter-process communication. So this is the diagram of the microkernel based operating system structure. So here there are the application inter-process communication, file server, device driver, Unix server, and the second, this part is the basic inter-process communication, virtual memory scheduling, and the final one is hardware. So let's discuss about this diagram in a brief manner. So in the above diagram, the microkernel contains the basic requirements such as memory, process scheduling mechanisms, and basic inter-process communication. So the only software executing at the privileged level. That means that the kernel mode is the microkernel. The kernel mode is nothing but the microkernel. So the other functions of the operating system are removed from the kernel mode and run in the user mode. So these functions may be device drivers, file servers, and application interprocess communication, etc. So let's discuss about the essential component. What are the main components used in a microkernel? So a microkernel contains only the core functionalities of the system. So the minimum functionalities included in a microkernel are, the first things are the memory management mechanisms. The memory management mechanisms are like address spaces are included in the microkernel, and this also contains memory protection features also. And the processor scheduling. Second one is the processor scheduling mechanisms are also necessary in the microkernel. So this contains process and thread schedulers. And the third one is the inter-process communication is important as it is needed to manage the servers that run their own address spaces. So let's discuss the performance, like how microkernel system performs. So providing services in a microkernel system are much more expensive than in a normal monolithic system. It means the monolithic system means, as we discussed in Unix, and so the service is obtained by sending an inter-process communication message to the server and getting one in return. So this means a context switch or a function call if the drivers are implemented as processes or procedures respectively. So performance can be complicated in microkernel systems and may lead to some problems also. So however, this issue is reducing in the modern microkernel systems created such as L4 microkernel system. So here we'll see the more benefits. Here are the more benefits of microkernels. So microkernels are modular and the different modules can be replaced, reloaded, modified, changed, etc. as we required. So this can be done without even touching the kernel. So this is the main benefit, and the microkernels are quite secure as we discussed earlier. So as only those components are included that would disrupt the functionality of the system otherwise. So microkernels contain fewer system crashes as compared to monolithic system. So also the crashes that do occur can be handled quite easily due to the modular structure of microkernels. So this is about the microkernels, and thank you so much. Please stay tuned for the further videos. We will discuss about the overall the operating system structures, and please do like and share with your friends, and please subscribe to the Code with Us channel. It's very helpful, and thank you so much.